Hey everyone, welcome back, and today let's solve Leetcode problem 2501 titled Longest Square Streak in an Array. So we're given an integer array nums, and a subsequence of nums is called a square streak if the length of the subsequence is at least 2, and after sorting the subsequence, each element except the first element is the square of the previous number. We need to return the length of the longest square streak in nums, or return -1 if there is no such square streak. And so a subsequence is an array that can be derived from another array by deleting some or no elements without changing the relative order of the remaining elements. So in example 1, we have the input array nums to be the following, and we'd output 3, because if we can choose the subsequence 4, 16, 2, after sorting it becomes 2, 4, 16, and 4 is the square root, or 4 is the square of 2, and 16 is the square of 4, the number before, right? And they give us a nice algebraic definition or explanation of why that is. 4 equals 2 times 2, and 16 equals 4 times 4. And so 4, 16, 2 is a square streak, and it can be shown that every subsequence of length 4 is not a square streak. 3 is the length of the longest potential square streak in this input array nums, and so that would be the value we'd output. In example 2, we have the input array nums to be 2, 3, 5, 6, 7, and we'd output -1 because there is no square streak in nums, so we have to return -1. So with that out of the way, and after looking at the constraints here, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so the first thing that may come to your mind might be dynamic programming, right? And this at first looks to be a pretty similar problem to Leetcode problem 300 titled Longest Increasing Subsequence, but you don't even need dynamic programming here. You just need some pretty intuitive it's a pretty intuitive solution, and it's mainly just logic if you really think about it, right? This sorting of the subsequence isn't really too important here. It just tells us that we can have any square of any number as long as it's actually in the input array nums, right? And we haven't used that before, right? So with that out of the way, let's just go ahead and dive straight into the code here. So I'm going to have a longest, which is ultimately what we're going to return, the longest square streak, and I'm going to initialize that to be 0. I could have called it longest square streak, but that would have been too long of a name to access, and so I'm just going to initialize it to be longest. And I'll actually get a num set to be equal to the set of nums, right? Because, of course, sets are going to have constant lookup and insertion times, and also, well, we don't really care about any duplicate characters, so it's a lot better for our runtime code and to be more optimal. Right, so once we do that, now we can actually start iterating through the input array nums and looking for potential squares of numbers we've seen so far in current iterations. So I'm going to say for I in the input array nums, right, just looping over all the elements in nums, I'm going to set my current value or element to be equal to I, and I'm also going to initialize my streak for this current iteration to be equal to 0. Right? So while the current is actually in our num set, and we'll update that manually, while it's in the num set, we can increment our streak by 1 because we've seen one more potential square in our current subsequence, and set current or update current to be equal to its square, to look for its square in the next iteration if it's in our num set or not, to update our streak. And after we see all the potential squares in this current iteration in our num set, we can set our longest to be the maximum of itself because we don't want to make it smaller, and the actual streak of the current subsequence in this iteration of our input array nums, and ultimately outside of this for loop simply return the longest value. But we can only return longest again if longest is actually greater than or equal to 2, because that's what is said in the in the problem statement of above. The length of the subsequence has to be at least 2. If that's not the case, they say explicitly that we have to return -1. So I'm just going to say else return -1. So this is pretty Pythonic here, pretty simple. We simply have to return longest if longest is greater than or equal to 2. Otherwise, we have to return -1, and that's about it. Pretty self-explanatory here. Unless I made any syntax errors here, this should be accepted. And as you can see, this is just about as efficient as you can get. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.